Hi everyone, my name is Shelby, and for the first presentation, I'm going to be talking about biopower, also known as biomass, biofuel, biogas. All depends on what the biomass was converted into for its energy purpose. Biopower is Earth's oldest form of energy. It dates all the way back to the early 1800s when our ancestors first discovered fire. They used this for obvious reasons like heat, but they also used it for cooking and for electricity as well. First, we need to talk about what biomass is. And biomass, it is the organic material that comes from plants and animals. It is renewable in two senses. One, the fact that it is energy that is stored and coming from the sun, and two, the fact that it can be regrown over a relatively short period of time. Whereas right now we're using fossil fuels at an extraordinary rate, and those are taking millions of years to reform. This is a great alternate solution because we have the power to grow it so quickly and at our fingertips. Next, we will talk about some examples of biomass and their uses for energy. We'll begin with a pretty common one, which is wood and wood processing wastes. These are burned to heat buildings to produce process heat in industry and to generate electricity. The second form of biomass is agricultural crops and waste materials, and these are burned as a fuel or converted to liquid biofuels. You see this a lot with ethanol and how it's formed from different agricultural crops. The next type of biomass, this is our everyday food, yard, and wood waste that you find in the garbage. This is what we take to our landfills. So this is burned to generate electricity in power plants or converted to biogas in landfills. And we also have the animal manure and human sewage. This is converted to biogas, which can then be burned as a fuel. And as previously stated, the alcohol fuels such as ethanol are also used. Now that we have looked at the different types of biomass, we can now talk about how that biomass is used for energy. So we'll start with one of the more common ones, which is burning. This process is done in special plants to produce steam for making electricity, or we can also burn wood to provide heat for industries or for our homes. And as most of you know, we can also burn wood to cook with as well. The next type of biomass energy usage is through the process of bacterial decay. And this is just as simple as the fact that bacteria feed on dead plants and animals. They produce a gas called methane. This is a completely natural process. It happens anytime waste is decaying, and methane is the same thing as natural gas, which is the gas sold by the natural gas utilities. The third process that we use biomass for is fermentation. This is where we add yeast to biomass to produce an alcohol called ethanol. This is how wine, beer, and liquor are made. Wine is just fermented grape juice. Another way to use biomass is by converting it. So it can be converted into gas or liquid, which is how we get the terms biogas and biofuels. This is done through chemicals and heat to form a reaction. For example, in India, they use cow manure and they convert it to methane gas, which produces their electricity. And the methane gas can also be converted to methanol, which is just the liquid form of methane. Now we're going to look at all of the different types of biomass in a little bit more detail. We're going to start with wood. As you see in the photo here, you see the wood scraps, you see the whole logs, and you see pellets, which is just a condensed form of it made out of scraps. So what's important to remember about wood and wood waste is that it's used for cooking and heating in developing countries, as they don't have the technology that we have in the United States. As I said earlier, energy in the mid-1800s primarily came from wood. And a little fun fact, in 2015, 12.5 million US households used wood as an energy source. May have just been a backup, but they still used it. And of that, 3.5 million used wood as their primary energy source. Looking at more recent data, in 2017, about 2% of total U.S. annual energy consumption was from wood and wood waste. And I wanted to just clear up the wood waste. That consists of bark, wood chips, any wood scraps, paper mill residues, and even the sawdust. In the United States, industry, electrical power producers, and commercial businesses are most of the wood and wood waste fuel consumed in the United States. The wood and paper products industry uses wood waste to produce steam and electricity, which therefore saves money because it reduces the amount of other fuels and electricity that must be purchased. Some coal-burning power plants even burn wood chips to reduce sulfur dioxide emissions. Now we will spend some time looking at the municipal solid waste that we generate here in the United States. This is also a form of biomass. This is the food waste that we produce, the various garbage items that we just take to the landfill, yard trimmings, paper, etc. Everything that we don't want that we take to a landfill is what the MSW stands for. So this contains biomass, which is what I just listed. Also, it contains non-biomass combustible materials. These are plastics and other synthetic materials. It also contains non-combustible materials such as glass and metals. And as you see here, I have listed some information from 2015 where we, as the United States, generated 262 million tons of MSW. Of this, 52.5% was landfilled, another 25.8% was recycled, 8.9% was composted, and only 12.8% was burned with energy recovery. Special waste-to-energy plants are used to burn this MSW into energy. In 2016, 71 U.S. power plants generated around 14 billion kilowatt hours of electricity from burning approximately 30 million tons of combustible MSW. Of this weight, about 64% came directly from biomass, and 51% of that was used for the electricity generated. These landfills use the gas to create energy. This is the methane gas that is used from decomposing biomass in landfills as well. Not only does burning waste produce energy, but it also decreases the amount of space that we need for landfill storage. This reduces the volume of waste by about 87%. Landfills can be useful for energy for two purposes. The first we already talked about with the municipal solid waste, and the second is through biogas, which is formed from anaerobic bacteria, which, if you don't know, anaerobic bacteria are bacteria that can live without the presence of free oxygen. These bacteria live in landfills and they decompose organic waste to produce the gas, which is known as biogas. This landfill biogas is 40 to 60% methane. The rest is carbon dioxide and small amounts of other gases. As most of you know, methane is the same compound that is found in natural gas, which we use for heating, cooking, and producing electricity. The typical process for biogas is that the landfills collect it, they treat it, and then they sell the methane. Some landfills use the methane gas to generate electricity. Methane, it can be very dangerous to people in the environment because it is flammable. It is also a strong greenhouse gas, and there are actually laws in order by the Clean Air Act that require landfills of a certain size to install and operate a landfill gas collection and control system. Some landfills reduce methane gas emissions simply by flaring the methane gas. Burning the methane produces CO2, but CO2 is not as strong as a greenhouse gas as methane is. In 2016, the United States Energy Information Administration estimates that approximately 278 billion cubic feet of landfill gas was burned for energy at U.S. landfills. 99% of this was used to generate about 11.2 billion kilowatts of electricity, or 0.3% of total U.S. electricity generations in 2016. The last types of biomass that we are going to talk about include human sewage and animal waste. As you can see in this photo here, looking at animal manure and the different components that is made up in the manure, there are a lot of beneficial uses. This photo comes directly from the EPA. First, we will look at the animal waste. Farmers are producing biogas in large tanks, which are called digesters. This is where they put manure and use bedding material from their barns into a large tank, and that produces the biogas. Some farmers also cover their manure ponds to capture the biogas. Biogas digesters and manure ponds contain the same anaerobic bacteria that is found in landfills. The methane in the biogas can be burned to heat water in buildings and for fuel in diesel engine generators to generate electricity. Now we will look at human sewage. In the Grand Junction of Colorado, the wastewater treatment plant is processing 8 million gallons of human waste into a renewable natural gas, also known as biomethane. This RNG is then used to fuel fleet vehicles such as garbage trucks, street sweepers, dump trucks, and transit buses. This is also made possible through the process called anaerobic digestion, which is what we've talked about with that anaerobic bacteria breaking down the waste into raw biogas. The biogas is then collected and upgraded to an RNG at pipeline quality, and it can be used as electricity, heat, or transportation fuel. We will conclude this presentation by discussing some potential concerns with biomass. As with any new type of energy, there's always going to be pros and cons associated with it. First, we will look at increased deforestation rates. This occurs when it comes to harvesting of wood and using that for energy. Wood and charcoal are major cooking and heating fuels in poorer countries, but if people harvest the wood faster than the trees can grow, it causes the deforestation. Planting fast-growing trees for fuel and using fuel-efficient cooking stoves can help slow down the deforestation and also improve the environment. When it comes to burning municipal waste, there's also the risk for air pollution and contaminated ash. Burning garbage produces air pollution and releases chemicals and substances in the waste into the air. Some of these chemicals can be hazardous to people and the environment if they are not properly controlled. The EPA requires waste-to-energy plants to use air pollution control devices such as scrubbers, fabric filters, and electrostatic precipitators to capture the air pollutants. Ash can contain high concentrations of various metals that were present in the original waste. They may contain lead and cadmium, for example. To help solve this process, it may be useful to separate waste before burning. This could remove batteries and fluorescent light bulbs, which contain mercury and other heavy metals. The EPA tests ash from waste-to-energy plants to make sure that it is not hazardous. The test looks for chemicals and heavy metals that could contaminate groundwater. Some biofuels, like ethanol and gasoline ethanol blends, burn cleaner and have higher octane ratings than pure gasoline, but they have a higher evaporative emissions from the fuel tanks and dispensing equipment. These evaporative emissions contribute to the formation of harmful ground-level ozone and smog. Another major concern associated with using biomass as energy lies in the crop controversies. Growing plants for biofuels is controversial because the land, fertilizers, and energy for growing biofuel crops could be used to grow food crops instead. In some parts of the world, large areas of natural vegetation and forests have been cut down to grow sugarcane for ethanol and soybeans and palm trees for biodiesel. An alternative to this problem would be creating ethanol with waste paper and making biodiesel from waste grease and oils, and in some cases even algae. This concludes my presentation on biomass. I hope you all have learned something new today, and thank you for watching.